AI. Thank you, Chris.
Awesome. Thank you, Greg. I'm going to move this over so I don't trip and fall over it. Hi, I'm Chris Stoner. I'm the Open Environmental and Geospatial Data Lead on the AWS Open Data team. So if you're not familiar with Open Data, we're going to start there. Then I'm going to show you how to use data that's in Open Data with Amazon Bedrock, and then we'll wrap it up with SageMaker AI. Hold up. There we go. All right, so Open Data on AWS. The program started about 10 years ago. Some customers came to us and asked that we put the Landsat archive into the cloud in one place because everyone was downloading this data set before they would start their analysis, and it makes more sense to have the data in one place where everyone can use it in the cloud, and then you just bring your compute next to storage. And a lot of folks have talked about this. Dave mentioned it in his talk this morning. And that's sort of how the Open Data program began. So fast forward to today, 10 years later, we have over 300 petabytes of data. It is open to the public, except for some of the healthcare life sciences data that has PHI or personal health information. That data is restricted, but if you're a genomics researcher, you will be vetted and be able to have access to that data. So you can think of Open Data as two things: the registry, which is our catalog of all of our data, and then the sponsorship program. So if you are a data provider, you have a data set, you want to make it available to the public, come talk to me, because the sponsorship program might be a good fit for you. We cover the cost of the monthly storage cost, so the S3 bill. We also cover the distribution costs, so you don't have to worry about spikes in egress. Let's say you have optical imagery, there's a disaster, and everybody wants your data. You don't have to worry about that big spike when everyone wants to download your imagery. There are limits and restrictions to the program. Probably the biggest one is the license. We require CC by 4, which is a very permissive license. If you really want more control, maybe you want a registration page before your data. You could be listed in the registry, so have your data set in the catalog if it's on AWS, but then not covered by the sponsorship program. And that allows you to do things like, you need a registration page, but the data still has to be free and open. If you do want to sell your data, however, that would be AWS Data Exchange, which is a sister team to us. And come talk to me, I can talk to you about that as well. So this is what the registry of Open Data looks like. Over 800 data sets. Each data set will have tools, tutorials, and code samples. There's QR codes for everything I'm going to show you, but the QR codes are also on the very last slide, so you don't really have to worry about grabbing them yet. I mentioned the sponsorship program already, but at a high level, we focus on high-value data sets, so you cannot empty the garage into the Open Data program. Really because we cover those costs, storage, and distribution. Some folks get really excited and they want to just put everything into Open Data so they don't have to pay for it. There's quite a bit of an onboarding process. You own the account, you own the bucket, you own the objects in the bucket. You'll put into the program what you want available to the public. We do not fetch from you and manage your data. I mentioned no paywall or registration, unless you really want that, and then you would not be covered by the sponsorship program, but you still could be listed in the catalog. And the data has to be free and open, again, with that CC by 4 license. We work with a bunch of people. I really should have added more. Matt's slide was better. We work with government agencies, commercial folks, nonprofits, pretty much everyone everywhere. We even have some IRS data, New York City taxi cab routes. It's a lot. But so I have all this data. Now, what can I do with it? I keep talking about using the data where it sits. And you can use the Amazon Bedrock service. It's our generative AI service. So it's fully managed. There are a catalog of foundation models that you can choose from. So Bedrock started where everybody else started. LLMs, you could pick the LLM that you wanted to use, create a chatbot, and talk to different documents within your business, right? Create a chatbot to have everybody figure out your wiki. But think about that on steroids. So you're building generative AI applications, you can experiment and build agents, but you can also light up a lot of environmental and geospatial data just using LLMs. You can use them as knowledge bases and then open them up, like I mentioned, with chatbots. You can also do fine-tuning, which I'll sort of show a better example later. All right, so hopefully this is going to run. No. Let me try that again. There we go. So this is the Registry of Open Data. I'm going to use a data set from NOAA called the Severe Weather Data Inventory. And to use this data set with Bedrock, I need a couple of things that are actually on this page. But the data itself, severe weather alerts, thunderstorms, unusual weather like snow flurries in Florida. It's a lot of watches and warnings. But I'm going to go ahead and browse the bucket right here in my web browser and just see what's in there. You'll see it's a lot of CSV files, watches, warnings, but it's all CSV, which means a language model will be able to read this. So that's why I'm doing this particular example. So if I go back to the page, there's a couple things I need for Bedrock. I'll need to know the region, so I have to launch the Bedrock service in the same region that the bucket's in. I don't want to go cross-region. And I'll need the bucket name, which I have from this page, and I also need the account ID, which I can get from the SNS topic. So if I go over to Bedrock, if you've not used Bedrock before, I think we actually got rid of this. I don't think you have to turn on models, but if it says no models are, you don't have any access to any of them, just go in here and enable a bunch of models so you have something to choose from. And these are all language models, but we do have vision transformers, so we have optical models as well. So I made sure that I launched in the same region as the bucket, which is US East 1. And I'm going to go ahead and create a knowledge base. So basically what I'm doing is I'm going to use the bucket that's the data that's in the bucket. I could do a structured data store, but I'd have to pull the data into Redshift, create a bunch of Redshift tables, then Bedrock would do SQL commands to talk to the CSV data. I don't want to do that because I want to show you knowledge base with vector store today. And there's trade-offs to why you would do each. For vector store, once I set it up, when new data lands in the bucket, I can simply hit sync and I'll get access to the new stuff in the bucket. With structured data store, I'd have to go into Redshift. I'd have to import the data into Redshift first. So again, trade-offs. So I'm going to give this knowledge base a name. And in the sort of like cooking show where you sort of put together lasagna and then you pull out the fully baked lasagna from the oven, I'm going to do that because it takes a long time for this to run. So we're using S3, so I didn't have to make any changes to the first page, but this page is where it gets interesting. So I'm going to say other AWS account, and I'm going to go back to the Registry of Open Data and copy that AWS account ID to the clipboard. I'll paste it. And then for S3 URI, I could do an object, I could do an entire folder, or I could do the entire bucket and say just import everything. I want you to go ahead and create embeddings for the entire bucket. And that's what we're going to do in this case. So I'll go back to the Registry of Open Data. I'll copy that bucket name to the clipboard and then just paste it into the URI. Don't need to make any changes here. I'll hit next. I'm going to forget to do the model, but I'll go back to that in a second. If you used Bedrock about a year ago, under the covers it was OpenSearch serverless. But we have this new Amazon S3 vectors in preview, and I'm going to use that today. You could use Postgres or Neptune, which is a graph database, which are great for some other use cases. But again, we'll use vectors, which is in preview, or was when I did this. I think it's actually GA now. So it's going to give me an error, and then I'm going to select a model. So what this model is, this is a language model that I'll use to understand what is in the CSVs and create the vector embeddings. So that's my embeddings model. I'm just going to use Titan and I'll hit create the knowledge base. Create knowledge base is really pretty quick. It's just creating the place to store the embeddings. Where it takes a really long time is to actually go sync. That can take minutes to hours to days, depending upon how much data you want to plow through. So you'll see in this case, I can't test the knowledge base because I haven't synced the data set yet. If I click that sync button, then I have to wait. So I'm actually going to switch over to another one in a second. I think I do sync again for some reason. I really should have fixed that. But once it syncs, then the test knowledge base button will become available. And here's the one that's, yeah. So the lasagna that wasn't baked was SWD test 1, and this is SWD test. You can see that it synced because there's some warnings, probably a file size too big for Bedrock or a file type it doesn't understand. Now I'm going to use a chatbot. So I'm going to use Nova Lite because it's pretty cost effective. And I'm just going to paste some prompts in. And I can start with something really generic like, what types of data are in this knowledge base? And remember, we're using the severe weather data set. So what I get back when I ask these questions are things like lat long, time, shear of the radar cell, things that are really specific to my data set. What types of warnings has KBox received? That's the Boston Next-Red ground station. And I can see severe weather storm, special marine, and a couple of others, which makes sense. Boston's on the coast. I can look at warnings for specific areas, and I can also look at the source chunks, which is in the embedding space, where it actually grabbed from the CSV, which CSV it found this data. Again, you probably get better results if you do the structured data store through Redshift, but the trade-off is that you don't get newer data. When new data lands in the bucket, I hit the sync button, wait a couple of minutes, and then I just have access to new stuff. Last I did tornado warning types. KBMX is Birmingham, so that makes sense. So the idea is that we just took fairly complicated watches and warnings data that typically requires someone knowledgeable in the field to understand and just opened it up to a chatbot. So imagine you're an insurance company and you want to know, or maybe State Department or a local department that's worried about incoming watches and warnings, you can just ask questions of this chatbot and get that information back. All right. So now we're going to pivot to what if I had a geospatial foundation model and how could I use that? So if you go into Bedrock today, which is, you know, again, the place to do generative AI in Amazon, there are language models and quite a few to choose from. There's vision transformers, which allow you to create images like the Back to the Future image that, that Matt had in his slides a second ago. And there's also video language models that will create things like create photorealistic video of a bunch of nerds sitting in a conference room, and it would create a video of all of us sitting here, something very similar to what you see in the room right now. What we don't have, geospatial foundation models, environmental foundation models, but there's some stuff in progress. So I'm going to show you what a geospatial foundation model looks like when it runs on SageMaker. So we took the Made with Clay, the Clay foundation model. A couple of folks in-house put together a bunch of code, a pipeline. I'm going to walk you through that really quickly. But if you want to know what a geospatial foundation model is, how is that different from what's already out there? You basically take a vision transformer and adapt it for geospatial data. You want to give it the positional embeddings, where is this data located on the Earth, and multiple channels, like maybe it's not just optical, maybe you have additional bands that are going to be available. Out of the box, you can do things like similarity search and change detection without doing all the complex algorithms that we know and love. You can do it just using the vector embeddings, and I'll show you that really quickly. And then last, if I don't run out of time, we'll do minimal fine-tuning for land classification. I have a QR code at the end that will link to this. Everything is open source, so you can actually run this, but briefly, what this architecture is doing, we're going to grab some data from the Registry of Open Data. Will be Sentinel-2 data. We're going to retrieve the Clay model weights. We'll deploy the model. Then we're going to generate embeddings for that new Sentinel-2 data that the Clay model hasn't seen. So It was trained a year and a half ago, maybe 2 years ago, so I'm going to pull in data from after that. Once I generate the embeddings, then I'm just going to use the embeddings as is. So we'll run a similarity search. So I have a chip, it's forest, find more chips that look like this one. We'll do embeddings along a time series. So for this patch of earth, show me how it has changed over time. So now you can do change detection kind of on the cheap. And then last, we'll have a fine-tuned custom head that will do land classification. Okay, so I said everything's in the GitHub repo. I have a link to this in the end. There's a couple of notebooks. So now I'm in SageMaker AI. I'll create a Docker image. This will allow the clay model to run on some GPU instances. Then we're going to build and register the Docker image to do the geospatial processing. This is breaking that image down into chips that, 256 by 256 size chips that Clay can then process. And then we run a big processing job. This is a pipeline. I'm going to show you what that looks like in SageMaker. So you can see it's got each of the steps. It will go through them depending upon your area of interest and how far back you want the data to go. This can take hours to a day or two to run. So definitely create a Cost Explorer billing alarm if you're worried about exploding your bill doing this demo, because this is not going to be on a free tier. Okay. When it's completed, there's a little snazzy Solera front end that we created. But what we're going to be able to do is map similar vegetation, which I mentioned. I have a chip that looks like forest, find me more forest. Then we'll detect ecosystem change, which is that same chip over time. And then last, fine-tune a surface model. If I could fast forward, I would, but I can't. What can I tell you about each of these before we get into it? There's a spot at the end that I'm going to skip, which are the use cases. We have several. You'll see that when you launch the web front end. If you have more use cases that you think you could use this, reach out and let us know. So there's a couple things we did sort of up front. We're using the Amazon rainforest for the area of interest. And I'm just going to pick just a random chip on the map. It looks like forest. I want to get back 100 similar items, and I want a similarity score of at least 0.4, which is actually quite low. It runs really quickly because it's just searching through the embeddings. It has not gone back to the original Sentinel-2 imaging at this point. So I can see a bunch of, it doesn't look really great on this screen, but they're forest chips that look very similar. Mostly forest, maybe a little bit of cloud cover in there, but if I show the results on the map, which I'll do later, you'll see why that's interesting. So now I'm going to pick something a little bit different. This chip has about half, maybe 3/4 of the image. You can see that they have mowed down the forest at this point, so they're land clearing, probably getting ready to plant crops. I'll keep the same values. Run the search again. Again, it comes back really quickly. You can see the similarity scores are still very high and very similar situations where there's a good bit of clearing, but still patches of forest. Why is this interesting? Well, if I show the results on the map, these are probably areas where we want to go in country and see if we can do some remediation. Stop mowing down the forest, please. Can you go plant your crops somewhere else? Because the Amazon rainforest is really important. So think about if you were a national government, you want to be able to see these things without having humans on the ground. You can do this. This is not hard. Everything's open sourced, so you'd be able to do this monitoring from space. Now we're going to do ecosystem change. So one patch of Earth, instead of many patches of Earth, one patch of Earth changing over time. We pre-computed a change intensity just to help us find chips that were very active. And I'm going to pick probably the same chip that I used in the last one, which has a high change intensity. That just means it has changed starting back in 2018 through 2024. It has changed quite a bit over time. And we're going to select a couple of examples so that you can see. Move ahead a little faster. I've got one more to go. So the idea here is really that we want to be able to start from something that had a lot of forest and moved to not a lot of forest and be able to pick that up. And you can see that if you click through, again, there's a true color slider at the bottom that does something very similar. And the last demo that I'm not going to have time to show you has almost this exact same UI, but what we did was, so okay, this is very foresty, it looks pretty good. There's some activity where they've been clearing trees, but if you, 2018 to 2024, if you slide the slider back, you can see they've really been active. There's quite a bit of land clearing here. The last bit I won't have time to show you is the image classification. We basically took where we were at with this model and then created, we did some fine tuning, gave it some labeled data. This is forest, this is rangeland, these are crops, and had it run over this, a similar area of earth. And it was able to pick stuff out, which was able to show over time things like it went from forest to rangeland and then went to crops. So you can see not just that something's happening, but you can actually classify exactly what's happening. Again, this is just using the embeddings. I never actually went back to the original imagery once it was pushed into the foundation model. So I'm just going to let that run. I think I'm completely out of time, but please come talk to me after. And I have really cool stickers up here if you want a sticker.
Questions for Chris? Use the microphones because we're recording.
Cool, yeah. I was just wondering if you went with the Redshift option, with that, would the LLM actually be generating the SQL queries to, oh, okay, cool.
Exactly right. And I have a blog post on that. If you come up to me later, I can send that to you.
Cool.
And it wants to exactly how to set that up.
Any other questions for Chris? Must be plenty of questions.
So with this land use classification or land cover classification, does that model use like only the spectral data, or does it also use object-oriented features to do the classification? Do you know?
I did not actually create the land classification, but my understanding is that it was just spectral and it's kind of rough. So we took labeled data from OpenStreetMaps, I believe, and stuffed it into the model so that it could see chips like this are forest, so other chips will also be labeled forest. I mean, we didn't spend a lot of time on this at all. It was kind of like, what could we do really quickly to show art of the possible? And then just sort of like, here, community, go grab it. So I think it's done at this point. So I really wanted to end here. These are the QR codes for everything that I showed, Registry of Open Data, the clay model, here's how to get the model, the embeddings. You can use the embeddings straight out of the bucket. You don't have to train or run anything if you don't want to. Open Data plus Bedrock blog post. Here's how to use a knowledge base within Bedrock. And then last but not least, Open Data plus Geospatial Foundation Model blog post will walk you through how to launch and run everything that I talked about. Give yourself about 6 hours to put all that together.
Great, fantastic. And I should know, do you have one last question? Yeah, please.
So yeah, Chris, you said that the license requirement was CC. Is that new? Because I thought I recalled some early data sets that were like US only and...
Okay. So yes, so if you actually go through the Registry of Open Data or just have Kiro or something else write you a quick search, you'll see there's a variety of licenses in there. Please check before you use. We have made some changes over the years, but we do require CC by 4. We do not allow CC by NC, that's the non-commercial license that is similar, on purpose. I mean, that's the value exchange for us paying for the data set to be there. But folks that want NC, some of those are listed, but they probably are not covered by the sponsorship program, meaning I'm not paying the bills, so I'll give a little more leeway to what they want. So long as it's open to the public and on AWS, you can still get listed. I was given to me.
Thanks, right. Thanks, Chris. Round of applause for Chris. Thank you for the presentation.